Hi students, welcome to my YouTube channel. In this video, I am going to solve some of the previous year question papers on nuclear physics. Before going to start, please subscribe my channel, press the bell icon for notifications so that you will get the information regarding upcoming videos. So let us start. So the first question is, the nucleus of oxygen is assumed to be spherical with a charge radius r and volume v. Based on the empirical observation on the charge radius of the nucleus xenon, one finds the volume as. So we have to find out here volume of xenon with respect to oxygen. So we have the equation for radius in case of nuclear physics, that is r equal to r naught into a to the power 1 by 3. So we have the oxygen and xenon. If we take the ratio of the radius of these two molecules, these two atoms, let us consider r and r prime radius of these two, oxygen and xenon. Then mass number of oxygen 16 by 128, because radius is proportional to mass number. So 1 by 3, 1 if we divide it, we will get 1 by 8. 1 divided by 3 is equal to 1 by 2. Then r prime is what? Twice of r. If radius of xenon is twice of radius of oxygen, then what will be the volume? The equation has been given. Volume is proportional to what? R cube. So volume of this xenon is equal to 8 times volume of oxygen. So the correct answer here is the characteristic time of strong interaction is. The options has been given: 10 to the power minus 43 second, 10 to the power minus 2 second, 10 to the power minus 15 second, 10 to the power minus 23 second. As we know, strong interaction, that is nuclear force, which is short range force. So that is order of 10 to the power minus 23 second. So if we consider minus 2 and minus 15, that is for weak interaction. Okay. So the correct option among these will be option D, 10 to the power minus. So the next question, choose the correct statement regarding spin and isospin of sigma hyperon. So the options has been given. So as we know, sigma hyperon is an elementary particle. So we have three kinds of hyperons: sigma minus, sigma naught, sigma plus. So all these type of elementary particles of sigma hyperon have the spin half and isospin, that is I is equal to 1. So as we know, proton, neutron, they have isospin half, but for hyperons they are having spin half as well as isospin 1. Okay. So if this is the condition, then option here given, option C is the correct answer, spin half. And which is the correct binding energy curve? So if we observe all the four given option, the curve, the binding energy per nucleon, if we plot the graph of binding energy versus mass number, so option B, if you observe, this is the correct. All these three are not correct. So option B, if we see, it is exactly what we study for the binding energy curve. So the maximum binding energy for iron, that is about 8.8 mega electron volt. So this is for low Z elements binding energy is low, and for high Z elements it is maximum. So the option B is. So the next question, let P and N denote the proton and neutron state. With the value of isospin quantum number I is equal to half and the third component of isospin I3 equal to half plus or minus half respectively, which of the following two nucleon states has isospin I equal to 0 and I3 equal to 0. So if you observe the four options carefully, the state vector, as we know, proton and neutron are the particles which have spin half, that obeys Fermi direct statistics. So they are indistinguishable particles. If we interchange the particles, they are indistinguishable, but they are having the spin half, that is half integral. That's why they indicates the antisymmetric wave function. So here if you observe the four options, correct option antisymmetric wave function, that is given by option A, minus. If you interchange the particle, antisymmetric wave function that obeys Fermi direct statistics, half integral spin. So the correct option is state spin parity of boron is. So here in the question they have given the boron that has mass number is equal to 11, atomic number is equal to 5. So the unfilled states for this boron is given by P 3/2. Okay. Then spin of this boron is given by 3/2 and the value of angular momentum that is given by 1. That is if you take SPDF shell, so there are 5 protons, so they will exist in P shell, 1 of the electron, so L is equal to 1. Then parity is given by minus 1 to the power L. L equal to 1 minus 1 to the power 1 is equal to minus 1. Then the spin parity is given by 3/2 minus. Okay, the correct option is. Question is, according to Fermi theory of beta decay, the decay constant lambda varies as the end point energy E0 of electron has. So here options has been given. So this decay constant is directly proportional to energy. So by what power? As we know, this decay constant lambda is equal to 0.693 divided by half-life. Okay. So the decay constant in terms of energy for initial and final state, we have the formula like this. So you can see here the maximum energy is the power of fifth. So this lambda is proportional to e to the power 5. So correct option is here E not 5, that is end point energy. And as we know, binding energy is high for hazard elements. So this decay constant is proportional to the fifth power of E naught, end point energy. Charge conjugation invariance does not allow the reaction. So the charge conjugation means the particle must be changed into its antiparticle. Antiparticle means one should have the positive charge and another must be negative charge. If you observe these options, why not? If we want to have, one must have the positive and negative charge. So this is okay, and B is also valid. Okay, why not? If you take one must be positive charge, another must be negative, and one more must be positive, maybe negative. If we see this equation, that is not going to be balanced. So why not? That is neutral. If one is positive, negative, then that must be neutral. So the option C is not valid. So if we see option D, so this is okay. D is valid. So option C is not allow the reaction. Okay. Options. Option respects the following conservation laws. If we consider weak interaction, among these, strangeness, parity, charge, or combined parity and charge, which among these are going to conserve? So option C is correct. In case of weak interaction, charge is going to be conserved. So strangeness, parity, so that is not valid. So option C, if we take combined parity and charge, that is also not going to be correct. So option C, charge is going to be conserved in case of weak interaction. I hope this video is helpful for you. So if this video is helpful for you, please like, share and subscribe my channel. So thank you for watching.